Okay, a very good day to our lecturer, Dr. Ibrahim Hamid Hussein Al-Kadami, as our BFC21201 Hydraulics and Mechanics of Materials Laboratory for Section 7. So today, me and my group from Group 3 will do a presentation about our lab hydraulics. Okay, so this is our group member for Group 3. We have SYAHIRAH binti Noh HASHIMY, SITI AISHAH IBRAHIM, SYAZWAN HADI bin Muhammad SUHAIMI, MARCELLINUS HASSAN, and the last one Muhammad RAZIEF bin RAMELI. So for our group, we will do a presentation for every lab that we have done, and we will do a discussion based on the data and analysis of the result that we have collected for our lab. So I will pass to our next presenter. Thank you.
Assalamualaikum. My name is SYAHIRAH binti Nur Hashimi alias Nur AZMY, and my metric number is CF2200121. I will explain for the first lab, which is basic hydrology. So let's start with introduction. Hydrology studies water from land to ocean, focusing on precipitation measurements in various locations. It helps predict floods and extreme rainfall events and correlates precipitation with stream flow patterns. Hydrologic measurements are used to determine river flow, water storage requirements, spillway design, urban design, evaporation, and irrigation requirements. The hydrologic cycle consists of four parts: precipitation, surface runoff, stream flow, groundwater flow, evaporation, and transpiration. This cycle is crucial for maintaining life and ecosystems. So the objective for this lab is study the components of the hydrology cycle, including precipitation, evaporation, infiltration, runoff, and groundwater. The equipment that we use in this lab is basic hydrology instrument, stopwatch, and rain gauge meter. The procedure for this lab: first step, for case 1, make sure that the water level, slope, and rain gauge meter are zero and water bubble is centered. Next, turn on the switch pump and start the stopwatch together. Step number 3, record the reading for rain gauge and water level for every 30 seconds. Step number 4, the pump was switched off after the reading water level and rain gauge obtained the same value constantly 6 times. And the last step is step 1 to step 4 was repeated for case 2 with the slope adjusted to 3 cm. This is the result for basic hydrology lab. The data was recorded every 30 seconds, which is include case 1 and case 2. We need to record the water level, discharge, and rain gauge reading. This is the analysis that we get from the recorded data. So here have two graphs for case 1 and case 2. The x-axis is time in second and y-axis is discharge meter cubic per second. From the previous slide, from the graph that we do, we get a straight line. So from the straight line, we draw a new table to calculate total flow, base flow, and direct flow for case 1 and case 2. So this is the comparison experiment result of case 1 and case 2, which is the time concentration for case 1 is 120 to 210 and case 2 is between 150 to 210. The rainfall duration is 180 seconds. Same for case 2. The peak discharge for case 1 is 0.000144 and case 2 is 0.000138. Runoff volume is 1.2924 for case 1 and for case 2 is 1.9728. Rainfall intensity is 0.0611 for case 1 and for case 2 is 0.0677. The storage volume for case 1 is 4.612 and case 2 is 2.761. After the comparison, these experimental results from the table, the slope affects the value between case 1 and case 2. When the slope is increasing, the quantity of runoff will decrease. So from this basic hydrology lab, we can conclude that it helps understand water behavior in the environment, demonstrating rainfall spread, runoff, slope influence, and soil properties. It helps understand how water moves through the environment and the factors influencing its movement, allowing for better understanding of its movement. That's all for lab basic hydrology.
Okay, first of all, I want to introduce myself. My name is MARCELLINUS HASSAN, metric number CF20208. Okay, so for infiltration rate experiment introduction, we can say that infiltration is a type of process which the water on the ground surface enter through the soil. So infiltration rate in soil is a measure of the rate at which the soil is able to absorb the rainfall or irrigation. Okay, for the objective, we have to determine the infiltration rate of particular areas of soil and to explore and determine the features of the subsurface condition which are the need of soils where the water infiltration rate into field soils. Okay, so this is our material and equipment that we'll be using for infiltration rate experiment. We have inner and outer ring, driving plate, stopwatch, ruler, hammer, and also a pail. Okay, so this is the data result of analysis that we have collected. So based on the graph that we have plotted, shows that the infiltration rate versus time become decreasing. So on the first 60 seconds shows that usually the infiltration rate are in high, but after that another 60 seconds shows that getting slow because due to the water absorbed by the soil become slow. So it shows that that's why the infiltration rate become decreasing for another 60 seconds until it reach constant value of that infiltration rate. So when the infiltration rate versus time are decreasing, we can say that the infiltration rate capacity versus time will increasing. So in this discussion and conclusion, we can say that different type of soil will affect the infiltration rate. We can say that the rate of infiltration will increase whenever the soil is in dry condition, while the rate of infiltration will become decreased whenever the soil is in moist or damp condition, and it will occurs very slowly with saturated soil. So that's all from our group for infiltration rate experiment. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad RAZIEF. Today I want to present about flow in open channel. This is an introduction. Hydraulic jam occur in open channel flow when high velocity liquid flow into a low velocity area. The liquid surface rise due to the conversion of kinetic energy into potential energy and dissipation due to turbulence. There are two main forms of hydraulic jam. First one at a low speed and at a high speed. Okay, this is our objective. First one is examine the hydraulic jam. Second, observing the hydraulic lag phenomenon and constructing. Thirdly, to look into the feature of a standing wave or hydraulic jam. Okay, this is a part A for result. The hydraulic jam. Where opening YG upstream flow deep depth, Y0 flow depth above jam, Y1 flow depth below jam, Y3 flow rate Q. Those value we got from experiment. and H V1 H per H over Y1 Y3 over Y1. Those value we got from calculation. Next, this is a part B, the force on a solid gate. The formula we use to look for the gate thrust. The rho we use 1000 kilogram per meter cube, and the G is 9.81 meter per second square. For the hydrostatic thrust, we got value here. For example, we got 1446.98. For FG per FH, we got the value minus here. For example, minus 682.33. And lastly, for YG over Y0, we got 0.0781. Next, those are our graph for part A and part B. For part A, the hydraulic jump, and part B, the force on the solid gate. This is a conclusion. When fast moving water slow down, it jumps out in height. This jump displays some of water energy. A wide opening allows more water flow through, increasing the water velocity. For a consistent experiment, the water flow rate should remain constant.
So, next is franchise turbine. Introduction. Franchise turbines are widely used in hydroelectric power plants. They are reaction turbines analyzing water pressure and reaction to generate electricity. Water enters through a screw case, increase velocity and directing it to the turbine runner. The runner has a foil-shaped blade that creates lift, causing rotation. A rotating runner shaft connects to a generator, converting mechanical energy to electrical energy. They are highly efficient, achieve over 90% efficiency. Versatile, operating under various water, heat, and flow conditions. Most widely used type of water turbine globally. Objective: understand the operating principle of a franchise turbine, a widely used hydropower turbine design. Analyze the performance characteristics of a franchise turbine, including its efficiency, power output, and speed. Learn about the design component of a franchise turbine, including the spiral casing, wicket gates, runner, and draft tube. Gain knowledge about the application of franchise turbine in hydroelectric power generation. For methodology, we use distributor leverage, valve, pressure meter, and digital display. Next, for the procedure. First, set the distributor leverage at the chosen value, Z equal to 50%. Switch on the digital display and the pump. Open the valve slowly until it reaches the maximum pressure. Set the load control trimmer by 5 parts. The division of this part are 0%, 25%, 50%, 75%, and 100%. Record the reading for speed, voltage, current, flow rate, and pressure. After collecting several series data, before proceed with the next gear, make sure close the valve and the pump switch. Set distributor leverage Z equal to 100%. Then continue and proceed the procedure similar to Z to equal 50%. So, result from the experiment, we collect data from distributor leverage 50% and 100%. We collect the all data that we got and we put in on the table. After that, we make a few calculations to get a water speed, kinetic, pressure, total head, mechanical power, hydraulic power, and turbine efficiency. After that, we make a graph refer to the table that we make. As we can see, the first graph is rotation versus motor speed. And second graph is turbine efficiency versus motor speed. And the last one is discharge versus motor speed. For conclusion, experimental analysis determine primary characteristic curve under partial load for both constant speed and pressure. High efficiency is not achieved at a low discharge due to fixed runner blades. All factors must be considered to maximize turbine power output. High efficiency hydroelectric generators should consider flow rate, velocity, power, and area efficiency. Outlet power is affected by the high difference between the pressure measure level and receiver brake level. Result indicate turbine velocity, increased flow rate and hydraulic power, efficiency manual mechanical power decrease with increased velocity, same power same flow rate can produce different velocities. Turbine capacity determine water velocity, power and efficiency.
Assalamualaikum. My name is Siti IBRAHIM. My metric number is CF21201. I will explain about pattern turbine for the group. Firstly, it's about introduction. A pattern turbine is a type of water turbine used for the generation of electric power. The ability of pattern turbine to function effectively over a broad range of flow rates and heats is one of their interesting characteristics. The objective of a turbine is to determine the operating characteristic of a Pelton turbine at various speeds. Next, about equipment and procedure, I have a list out the equipment that we use for Pelton turbine lab, and this is the procedure that we need to follow to complete the Pelton turbine lab. So this is our final result for this lab. We have 15 components that we need to find it. We already have W1 drum radius, volume and pressure. And others we need to find it by formula given in the lab sheet. Next, this is a analysis result that we do from a result that we get from a lab. So for part A, we want to know about rotation power against motor speed RPM. And for part B, we need to know about turbo efficiency against motor speed. And this is for part C, we need to find discharge Q against motor speed. So all this part A, part B and part C is already made in the lab sheet. So we need to analysis and then do a graph. Finally, it's about conclusion for this lesson to my lab. The Pattern Turbine Lab experiment provide valuable hands-on experience with impulse turbine technology. Through careful observation and data analysis, the experiment highlight the essential factor influencing the performance and efficiency of Pattern turbines.